Okay, Nikhil, thank you very much for the introduction and for your admin work, which is good work always, as I know you. And also good morning or maybe good afternoon for everybody listening to me. It is morning on my side, maybe afternoon on certain sides, because I'm talking to you from Manchester, England. I will try in this half an hour, because very busy I am. I have something else after this seminar as well. I'm teaching. As Nikhil been mentioned to you that the course is a 5 days course, 2 hours a day, so 10 hours contact. We give you the opportunity to question, to ask, and to learn as well. Very much possible, I give you some classwork and homework as well to do, to take with you. So I keep you busy in the 5 days, not only during the time, but also after the time. Production data, production nowadays is very important to keep it optimized, to keep it steady for an oil well or even for oil field. It's a challenge to keep the oil field producing a steady rate for a long time. Again, we will touch one day on the nodal analysis and the choice of the right production tubing, location of it, and the sizing of it. So in this course, which is a 5 days course, I just repeat what he mentioned, Nikhil. Our aim is very important about production optimization. What is optimization? Optimization in simple definition that, can I produce same amount with good quality, but with a minimum cost, with minimum problems? If I can maintain an oil well to keep it flowing steady, same rate, and same quality in terms of oil, gas, water produced, with minimum problems I'm facing. That's optimization, with the minimum cost I pay for. That needs from you to understand Darcy equation. How does a steady state flow or pseudo steady state flow, radial or spherical, linear, whatever, you need to understand Darcy equation in order to get that optimization. So I will touch on Darcy equation almost every day and explain the application of it and the problem we face. Challenges we face in production, as we call the formation damage. Formation damage can affect on the productivity and also can affect on the production, which we could face later on. And therefore, we will have session on a production, on skin factor, as well as on productivity index, and the IPR Vogel equations will explain that as well. The skin is a big issue. I will talk to about it today very briefly, give you a flavor of, but when we start, of course, we have a full day, 2 hours with no stop about the skin factor. So this, hopefully, if you attend this course and with me and you, we work as a team anyway, because I will talk to you and I will dialogue with you. You will learn at the end of the day the ideal and the perfect, I can say, productivity optimization. How can I do it? Is it choke size? Is it a tubing size? Is it the maintaining the wellhead pressure or the PWF? So on optimization, we talk about these factors. We will talk about the nodal analysis, which is very well known in choosing the right size of the production tubing, and also the relationship between what I call IPR and OPR, inflow performance relation and outflow performance. That's the idea of nodal analysis. We used to teach it by graphical way anyway. Nowadays, people use computer or sometimes maybe software to get a good idea. We do calculation of multi-phase flow as well. The IPR I explained to you. You will have some good examples, especially on Vogel equation. We will look about fracturing, especially if I have a formation damage. And to increase the productivity, fracture play an important part as well. Whether it is hydraulic fracturing or sometimes acidic fracturing. The importance of controlling the sand production using the well completion known as the gravel pack. I will cover that as well. The declining in performance, declining in pressure. Nobody can maintain the pressure of the reservoir forever. For sure, the reservoir with time, the reservoir pressure with time, there will be always a negative slope, dB by dt, declining. But can I make that minus dB by dt to be almost a small value? Can I make it steady? Can I make it horizontal? And that is part of optimization as well, maintaining the reservoir pressure and somehow by production or maybe by choke size or maybe by enhanced oil recoveries and so on. So in day one, we will talk about the skin factor and how can I estimate the permeability, the damage permeability, or sometimes maybe I use the well test, corner plot, for example, build-up test or drawdown test in order to estimate the right permeability. And what's the drainage area? How big the wellbore is sucking the oil from the surrounding reservoir. A drainage area, in simple understanding for it, consider it as a small reservoir, as a mini reservoir. It's a mini reservoir. It's a reservoir with one well. That's a drainage area, as simple as that. So the drainage area could be, for example, you say 40 acres or 70 acres for one well. And what's the communication between that area for well A with the area of well B? Do they communicate? Do they overlap? Do they have a clean communication between them? We're going to talk about this as well. If you have a reservoir with a good history, and there's example, for example, in south of Iraq, for example, I used to work in an oil field, a reservoir called Rumaila, developed in 1937. 1937. So it has a good history. Can I use that data in order to monitor the declining? Or at least I use this data, historical data, to predict the future of the reservoir? That's important as well for a production engineer, production reservoir engineer. I have damage around the wellbore or even in the reservoir. That damage may be caused by bad water injection, maybe by turbulency, maybe by failure in perforation and so on. So can I remove that, and how do I remove it? And can I monitor the performance after removing that? The stimulation by acidizing or fracturing, how they do it, I'm going to talk about it, to remove the formation factor or the formation damage. We will learn how to calculate the productivity index. I'm sorry, today I don't know. I just start coughing, I don't know why. As well, the principle of hydraulic fracturing. So day one is a busy day, very busy day. Of course, we cannot cover every single point in full details into us, but we will give you a flavor of. Then on next day, we'll talk about big other things such as asphaltene, organic decomposition or deposition, and the impact of well completion on the productivity, as well on the optimization. Sometimes if you have a bad completion or the completion has certain problems in it, you cannot You cannot get the right optimization. We'll talk about different completion methods. Nowadays, we will talk about smart completion. We'll touch on that. What do they mean by well integrity? We're going to explain that. Today, I will touch a little bit about well integrity, the barriers. There are 6 barriers they call primary or initials, and there are 6 barriers secondary, which we need to maintain them to keep the well healthy. Integrity is how to keep the well available, healthy, producing through the years. Some oil wells could stay with you for 40 years, 50 years. So how can I maintain the integrity of it? We're going to have a full session on that. The IPR, the inflow performance, again, Darcy for semi-steady state, pseudo steady state as well. Going to be Vogel, I mentioned to you, Vogel and IPR, and the productivity index, the shape factor. The shape factor has a connection with the drainage area anyway. That also will need to be explained. And it has also a connection with the productivity and optimization. We will have some touch on gas reservoir and gas well. What's the difference between gas well and oil well in terms of pressure, at least pressure? Gas wells, they have a big issue regarding the pressure depletion very fast compared with the oil well. So we talk about gas well and Darcy equation used in gas well. Darcy equation, you should modify it to use in gas well. You cannot use Darcy equation of oil well and gas well. No, you need to do some changes. We're going to mention these changes, as you know, because of the compressibility of the gas. The IPR, again, we talk about it. In day number 3, we have more things on IPR transient. We touch on nodal, choosing the right location for the tubing sizing as well, and also location relationship between IPR and the OPR. The perforation, I have a good session with you. I gave before a good webinar on perforations. So I will use perforation. I have so much information about perforation and also on penetration as well. We do that. We talk about deviated well, hydraulic fracture. Actually, my PhD is half of it hydraulic fracturing. Perforation and completion, gravel part. These I have a full seminar actually on different methods for well completion. I gave that seminar in 2 days workshop recently, therefore we have a good data on that. So hopefully day 3 will be very well covered. In day 4, the graphical analysis for the systems. We will touch on that. And how this sensitivity, what are the sensitivity? Is it delta P? Is it properties of the fluid, the reservoir properties? The tubing, we can show you later on how to calculate the right size for the tubing for any wellbore according to the data you wanted. So that will be learned as well. The nodal location, as we said, mentioned. I have nice slides and nice examples on that. How we analyze the production data. Production data are flow rate, pressure, GOR, water oil ratio, water cut. A pressure depletion with time and the pressure depletion with radius, location of the pressure within the pay zone. We will analyze that as well. The declining curve, the Arab's equation, going to touch on it as well, and many other things you're going to talk about. Integrity, intelligent well, I call it smart well completion, smart, as well as stimulation, fracturing, acidizing, and so on. I'm aware that I need to finish with you only half an hour today because I'm busy later on in my time. Day 5, again, we almost same trend, productivity of the wellbore, productivity index, the J factor, J index. The IPR, the care relationship between flow rate and pressure, both reservoir pressure and PWF. How do we apply Vogel equation and the outflow per production or outflow performance relationship? And we do nodal analysis. So the course will be quite busy course, nice data, nice information. I have to be honest, I cannot cover every single point in 2 hours, 5 days. No, but I will cover as much as I can. Maybe I give you some homework as well to cover the remaining. Hoping that when we start, I will start with you maybe with introduction, then I give you a pre-test. I have multiple choice questions. They are ready. I will examine you on it, and maybe if you don't finish on time, we can give it to as a homework. If we have any video clips, of course, I'm going to share it with you. You have the chance to discuss, question me as well. I will teach you how they do the troubleshooting in the oil industry. What are the principles of troubleshooting? Some case studies I bring with me from Iraq, from Oman, from Abu Dhabi, because I'm familiar with these areas, and also from Aberdeen, the offshore. We will have some good calculation examples, and also we have examples have real data. Then in the last day, we can do the post-test, which is same as a pre-test, but to compare how much knowledge you have. You cannot be an expert in 5 days. No, you cannot. But you will be aware. It will open eyes for you. You will leave and say, oh, wonderful, I need to pay more attention for this topic. Or, oh, first time I'm hearing about this topic. So it gives you the chance to develop yourself later on. There is no short course of training can change people into being expert, but raise the awareness. Your speaker will be me, Dr. Hussein. I am a professor of petroleum engineering, a freelance. I have more than 40 years of experience, 40. And 41 exactly, since I graduated. And since I graduated, I never ever stopped working in the industry, in the oil field, onshore, offshore. And then I changed into academia and research. And also I have my own training activities in different disciplines. At the moment, I am a director for a training company based in Liverpool, in England. I've been awarded on many times, and the best award, I'm proud of it, when I met Her Majesty, the Queen Elizabeth II, in the Buckingham Palace on 26th of April 2006, and she gave me the MBE medal for my good services for education and training, both inside UK and overseas. So I'm proud of that achievement to be appreciated by Her Majesty. What I'm going to do with you, just a testing example, just a example. I will talk about well integrity. And I talk about formation damage, skin factor, only as a sample because of the time, as I told you. I have only short time with you. Well integrity. The idea of well integrity, I have a well, been drilled, cased, cemented, perforated, production tubing, packer, wellhead. So my oil well is something like this, well completed, ready. Everything being done. It's cost me about $17 million to finish it and to make it ready for a production. So now when I start the production, do I have internal problem in the wellbore? I'm facing some kind of a leak or release of fluid between formations, between casings, between the packer and the upper part of the packer, between the annulus and the tubing, or the tubing and the annulus. Do I have any leaks in the wellhead? That's the idea of well integrity. Do I have good bonding between the cement and the casing? Do I have cracks in the cement? And why? Why? Do I have corrosion in the casing? Do I have formation damage in the perforated area or zone? Do I have block perforation? All this meaning of well integrity. So well integrity, as well integrity engineer, his job or her job is how to protect the well from getting damaged. How protect the well from getting intervened with the other fluid from the pay zone or from the surrounding formation. So they look into the cement, any cracks in the cement and why. The casing is a barrier, they call them barriers. The cement, the casing, the formation, the cab rock, the packer, the production tubing, these are barriers. And also there's barriers on the surface, the wellhead, the Christmas tree, the flow line, the choke, the gauges, the annulus between production tubing and the casing, production casing, the pressure build up, the reading of the pressure in the casing. Of course, casing should reach zero pressures, but with integrity failure, it will reach some pressures. How to release it as well. So integrity, I will talk very much about factors affecting on integrities. And these, as you see in this slide, are factors on the well design, cement plugs, maybe on the kick detections as well due to abnormal pressures, or maybe the mud pressure is not very high enough. We talk about the mud column as well, because mud column is also a barrier. The blowout preventer is a barrier. Any failure and deficiency is important. The way we are assembling the wellhead, the geology of the reservoir, natural fractures, fracturing of the cab rocks. A good example, a good case study for integrity is what happened in the Gulf of Mexico with the company British Petroleum. If you remember that, maybe there's also a movie for that called the movie, I think, Deep Horizon, if you have seen it. So that problem actually was very much integrity actually. It's a failure of the wellbore integrity. So the integrity, you talk about exactly the life cycle of the well. The life cycle of the well, starting from piece paper designing, and then drilling of the wellbore, the production of the wellbore, and the intervention. Intervention means, what do I do in the wellbore? Oh, you have done acidizing. You have done fracturing. You have done some kind of pack has been changed, for example. You have done well logging. You have installed an ESP, electrical submersible pumps. You have installed a gas lift. These are the intervention. during the life of the wellbore. We need to know them because these affect on the integrity as well. So the integrity is made actually of 3 stages. Stage number 1 is very much about the designing stage, or 4 stages. So stage number designing stage on piece of paper. Stage number 2 is the drilling. Stage number 3 is the production. Stage number 4 within the production, I can say the intervention, because these are connected to each other. The arrows is in and out between them. So they are one stage. So stage of design on paper, the stage of drilling, the stage of production and intervention. And finally, I want to abandon the well. I want to block it. How do I do that without any problems? These also will be mentioned in our integrity when I talk about it. So the well bore look like this. It could be a high pressure or low pressure or medium pressures. And the integrity has a factor on it. The blue and the red, the blue is within the well bore. They call the primary barriers. And the other barriers, secondary or general barrier, the red one. They are intervening between them because most of them, for example, they talk about casing and cement and the production tubing, but the secondary one can talk about the wellhead as well. So primary and secondary barriers, going to look into them and question yourself as an engineer why it is leaking, why it is not performing, because this will affect on optimization. Our course is optimization, and this affect on the optimization for sure. So this will be explained to you in details later on. I'm just giving you a flavor of what could be covered. Maybe some of you already attended some of my webinars, but here I'm just trying to give you a flavor of ideas. On the skin factor, again, an important factor could affect on optimization and productivity of the wellbore. We look into almost the life cycle again for the production in the whole reservoir. This starting from the point of discovery, development, whatever we do in the EOR process, primary, secondary, tertiary, until the abandonment. It's a life cycle. A life cycle of the, I can say, the reservoir, which again has a connection with the integrity anyway. So the life cycle of the reservoir is important, and that is very crucial to take in consideration. We're going to learn this as well, because it has connection with optimization as well, which is also has connection with integrity. I will touch about secondary recovery and tertiary nowadays is important, especially in mature oil field. People think about polymer injection, surfactant, CO2. I have a seminar on CO2 tertiary recovery on the 12th of the month. You can attend that if you wish. I have a webinar, free webinar. It's an important subject. So to understand this reservoir and reservoir behavior, you will start from the primary recovery from the natural derived mechanism, such as water derived mechanism or gas cap derived mechanism. Because at the end of the day, if you want to talk about optimization and how long the wellbore will stay with you, how much I can keep this wellbore alive and producing, and also the keeping the reservoir alive and producing, you need to understand primary recovery, how much energy I have in the beginning from the gas cap or from the water derived, or the combination of them. That will give you a vision, future vision for your reservoir. You can plan it in a proper way. And you can think, for example, okay, I can maintain or I can depend on a primary recovery at least for the coming 10 years. And then after that, I do my water injection. But if you don't have understand your gas cap size and activity or water derived size and activity, you cannot put a future, a plan for your well or for your reservoir. That we're going to explain to you by calculation. So formation damage is one of the things we can affect on optimization and affect on these productivity from water derived or gas derived. Formation damage has so many reasons behind it, many reasons actually. Could be organic issue, which is very much on the oil properties. Could be during the stage of construction and the stage of drilling and casing and cementing. Due to perforation process. Due to reaction or wettability or adhesivity between, or surface tension between fluid and sand or rocks. And the cementing I did. Did I choose the right cement? Good quality cement? And also the mud I use. High density, low density. Did I do under balance drilling? Or did I do over balance drillings? What is the mud I use? Is it just bentonite with barite? Or did I use foam or oil-based mud, diesel mud, and so on? Also, formation damage, it has a good connection with the history of the wellbore through the productivity index, the J factor, and the IPR. So if you have a completely wellbore and all of a sudden something problem on the production rate, and you said to yourself, nothing wrong with my tubing or my wellhead, so the wrong things is happen in the formation itself. What's make the barrier? What make that skin factor? Is it due to wax buildup, asphaltene? Is it due to scale buildup? Or is it due to the bacteria growth, for example, sometime, or turbulency, or damaging in the perforation? So these factors, I need to look into them, and I need to learn how to calculate the skin factor, whether it's positive, big value, or zero value, and so on. And how much it will change after stimulation, which I mean in this case, acid or fracturing or reperforation, and so on. So the skin factor could be coming from drilling stage due to mud filtrate and debris having from the drilling mud, essentially in overbalanced drilling. And these solid particles invading the area surrounding the wellbore, blocking the channels, and cause the black area here is very much an area of formation damage or invasion zone due to drilling. So sometimes you finish drilling and you spend the $17 million on the well, you open the choke, no oil comes through. Very disappointing moment, mainly due to we have a skin problem. So we need to understand that, and we need to remove it as well. Drilling an oil well is not cheap anymore. Just to pay for the drilling rig, sometimes you need to pay more than $30,000 per day hiring an oil rig. Can you imagine that? $30,000 per day. So every single day is counting. When you do the casing, cementing, wellhead, production tubing, and so on, the total cost could be add up to more than $10 million for only one well, sometimes up to 17 million if you do it offshore or a deep well or deviated well. So very expensive job, and therefore I want this well to stay with me for a long time, and that's the meaning of optimization. I want this well to pay back all the money I paid for that well. $17 million, you need time to get it back your money. If that well producing, for example, a 5,000 barrels per day, then you have to think how much I pay as operating costs and capital costs and so on. Understanding skin factor will help in understanding optimization. A skin factor is a dimensionless factor to tell you productivity and the health of the well. I'm going to finish in a minute. As well as the delta P skin, that's what you lose. I wish I have delta P skin equal to 0. I wish. Because that will save my money. The larger the delta P skin, I'm losing my money. Because it will be a barrier to stop production. And I lose a huge amount of pressure in a very short distance area from the wellbore. And that's not good. That's why I don't like the skin factor. So the skin factor, again, it is very much important to be understood in order to get a good understanding for the optimization. And this skin factor coming from drilling sometime or completion, reservoir, the way we talk about reservoir in terms of the oil properties, wax content, the way of perforation pattern, perforation density, perforation length, and many other factors need to look into, such as deviation and Darcy flow, turbulent flow. So the skin is something caused by many factors. Positive skin is very bad. Negative skin is very good, same as in COVID nowadays. If you say I'm negative, we say congratulations. But if you say I'm positive, then it's a problem. And therefore, we need to understand that. The skin comes from many factors, as you see, so-called total skin, the total skin. So the total skin is made of so many contributions to it. These are skin by scale or invasion, I mentioned to you. Perforation skin, turbulence, movement of fluid around the wellbore, turbulence with real numbers more than 4,000. Deviation in a certain angle also can give skin factor, gravel packing. Sometimes even stimulation, if it's failed, can cause skin as well. Temperature, because it will affect on the bubble point pressure and the release of gases. And we have a choke inside the wellbore. And sometimes temperature also affect on the integrity of the wellbore by weakening the casing. And also sometimes can come from natural factors. If you have so many natural factors in different directions, can cause them. So a skin will push you to understand Darcy equation. Very much important in this case. And you need to look into it in that terms. So we're going to talk about Darcy equation more than one time in the coming course. We will understand the basic one, the linear, the radial, the steady state, the pseudo steady states, the one with turbulency and so on. So understanding the radial area around the wellbore is very important for optimization, because this area is important. RE is the radius of the drainage area, external radius. We mentioned drainage area is a small reservoir surrounding the wellbore. RW is fixed value most of the time. Most of the time, RW equal to 3.5 inch, because most of 90% of the production casing is 7 inch in diameter. So that's almost fixed one. So we developed Darcy equation as well for both oil and, again, more than flow, I can say, incompressible radial flow with invaded zone. So we have also talked about the invasion. The RI is the invaded zone, the damage zone, i.e. the skin factor inside it. And this is the way they calculate skin factor as well. We're going to learn how to calculate it to get positive or negative. So I'm going to choose some examples. I'm here, I'm not training you, I'm just giving you a flavor what the course could do, and also you will understand the way I talk and the way I explain things. The trial. How we add a skin factor within the Darcy equation later on, and the impact of that as well onto the flow rate. We will add also delta PS as well into Darcy equation. So that Darcy equation, you should be flexible in changing it according to many factors: fracture, gravel pack, skin factor, steady state flow, pseudo, single phase, multi-phase. So Darcy equation should be clever how to deal with it. Formation capacity is important, how much oil in it in terms of KH. And Azir ratio between RE and RW. The RE is the radius of the drainage zone, and sometimes could be affected by the length of the fracture as well. We're going to talk about these. The IPR again is very important to be understood, and the impact of skin factor on IPR. The skin will reduce the productivity index. The Q over delta P will be affected. So I prefer something with no skin. Zero skin maybe have that kind of equation to look into. So we will talk about the positive, negative skin productivity index as well, how to calculate them, and adding other factors such as the D factor, which is the drainage area, which we mentioned in the outline, the shape factor. You need to consider that. We will learn how 0.75 came from where for the pseudo steady state. Productivity index, how to calculate the J factor as well. And simple equation or using Darcy equation, including the skin factor. PI with no skin and PI with skin. That also gives you a good idea about optimization. Relationship between the pressure, behavior or declining with distance from the wellbore. As I go away from the wellbore, what happened to the pressure? Should be an increase, of course. The pressure will decline as I am coming close to the wellbore. And that decline will be very much if we have more skin issues. Less skin issue will be better. And that's important. For example, I can say in case number C, I have less skin factor. Relationship between well pressure, well flow pressures, and the external pressure, sometimes called PR pressure, or in the beginning we have PR pressures. And we have different radius for the range area and radius for the total reservoir area. We will do some examples. As you see, we have some example here. Maybe we do calculation as well. So I used to teach in this university anyway, Teesside University. So this is my lectures from them. As I talked to Nikhil earlier, it will be a short session because I'm busy, and give you flavor of the course. And I hope, because I have only 6 minutes to start my other lectures. Nevertheless, I can see some things on the chat box written. Let me see what are they.